Hi everyone, my name is Dixon Chidubemi Federa. My friends call me Dubesoft. Today we are going to be solving a LeetCode problem. The name of the problem is Design Browser History. This is a medium problem. And the problem statement says that you have a browser of one tab where you start on the home page and you can visit another URL, get back in the history number of steps, or move forward in the history number of steps. Implement the browser class. So these are a list of this is the constructor, this is the method. So implement the browser history constructor with home page as the string. Initialize the object with the home page of the browser. Void visit, that is visit URL from the current page. It clears up all the forward URL. String back, move step back in history. If you can only return x steps in the history and steps greater than x, you return only x steps. Return the current URL after moving back in the history. At most, return steps. String forward, move steps forward in the history. If you can only forward x steps in the history and step greater than x, you will forward only x steps. Return the current URL after forwarding in history at most steps. This is quite a long problem statement and it has a tendency to get you confused, but just to simplify it shouldn't get confused. So this is an example here. It is the input that's given to you. You have this string of browser history, visit, back, forward, LeetCode. So the output should be just keep track of this. We started for browser history, visit, back, so back, forward. So we want to know our output. So these are output, no, forward, Facebook, Google, Facebook, no. So the explanation is here: browser equal to new browser LeetCode, browser history dot visit Google. You are in LeetCode, visit Google. Now it's visit Google. Now you are in LeetCode, visit Google. Browser history dot visit Facebook. You are in Facebook, visit. So you are just a matter of like you are in this particular page, you visit another page, you move there, visit this page, you move there. So you are entering a new URL. But if you come here, browser history dot back, now you are moving one step back. Initially, remember that you were on YouTube. Before you came to YouTube, you were on Facebook. So by the time you go one step back, you are moving from YouTube to Facebook. Yes. So we move a step back again. You're moving from Facebook to Google. Yes. So just like that. So that is how it's solved. So the constraint of this problem is one less than or equal to homepage.length and length less than or equal to 20. One less than URL.length, length less than or equal to 20. One less than equal to steps and steps less than or equal to 100. Homepage and URL consist of a dot or lowercase English letters. At most 5,000 calls will be made to visit back and forward. So this is quite a long problem statement, but not to get confused. What it's just trying to say is that maybe, let me use an illustration here. Maybe this is your browser. This is where you input your URL. So I'll skip HTTP. So let me say this is Facebook. Don't mind my writing. Don't have a proper mouse, but you understand what I mean. So this is facebook.com. So this is where you visit URL. When you put a new URL here, it takes you that new URL. So by the time you put on that, it takes you to that new page again. So by the time you move back, it takes you to the previous page before you moved to that new page. If you move back again, it takes you to the previous one before the next. If you move forward, it takes you to the next one before the previous. So just like that. So that's what's just one about. So let's say we have a button here. Let me put this a back button. So if you move forward, it takes you to the page. it takes you to the next. If you're in the back, if you move back, it takes you to the previous page. If you move forward, it takes you to the page, the next page. So that's what it just does. So that's all about this problem. That's all about the situation of this problem. So we want to be able to keep track of when we move forward and when we move back. So it's just like browser, just like we use your phone. Anytime you check your browser history, you see the number of pages. You see where you have moved, all the pages you have visited. So if you have visited Facebook, it will show there. Visited Google.com, visited YouTube. If you have visited YouTube, you'll see it there. So by the time you use the navigational button of back and forward, you'll be able to move back and forward as well. So to start with this problem, I'm going to be solving this problem with Java. So this is Java 8. So I'm going to be solving this problem with a map, and the map inserts and deletes at constant time. So I'm going to be solving with a map. So first of all, let me declare my variables. Let me call this current page. So let me call this on my max page. Yes. So let me initialize my map of integer and string. So let me call this a map. Yes. So I've declared my current. I want to be able to keep track of my current page. I want to keep track of the maximum page I've visited. So I want to be able to. I'm using a map to both store my web page and retrieve my web page. So this is my constructor. You can see that it has the same name with the class. So this is my constructor. So in this construction, this is where I'm going to be setting the initial state of my variables. So I will set initial state of my variable. So let me set current page to 1, and let me set max page to 1 as well. So to 1 as well. Then let me initialize my map. I declared it up there. Now let me initialize it. Let me create it. Got a new hash map. Yes. So let me put my. Remember, there is a initial. The home page is the starting page. So let me start with the home page. So map.put 1. So home page. Yes. So I've been able to initialize my variables and initialize my map. So now I want to visit a URL. So remember when I visit a URL, I want to be able to keep track of when I move forward and when I move back. So when I visit my current page initially 1. So when I visit a URL, my current page will increase to 2. That is the next page. That is 2. So I want to increase current page. Now I want to put this URL to my map. So map.put so my current page, now its current page is now 2. Then I want to put my URL into the map. Then I want to update my maximum page. So the maximum page I visited now is 2. So let me update it to current page. Yes. So I've been able to, when I visit, this is what I'll be able to put the new page, the URL of the page I visited, so into the map. Yes. So we want to be able to know when we move forward and backward. We want to be able to keep track of when we move back. Okay, this is the page that was visited, and we'll move back again. This page that was visited. So we want to be able to keep track of them. We want to retrieve those pages. So now remember, we are storing them in the map. Each page that we visit is stored in the map. So we want to be able to okay. If I want to go 2 steps back, I want to be able to go and retrieve the 2-step back page. That is if I visited google.com, YouTube, Facebook. Now if I go 2 step back, that is 3 minus 2. That is if I visit 2 step back, that is YouTube, Facebook, Google. So Google, Facebook. So one back, Facebook, then Google, the next step. So Google is the first one. That is 2 step back. That is going to be the first one. That is Google. So that's what you just mean. It's kind of confusing, but it's very simple. It's just a matter of understanding. It's a very simple thing, and it's just a matter of understanding the problem. So to do this, I remember I have my current page. So to be able to, I want to retrieve my current page. So I'll check. I'll check first of all. I'll check. I remember they give us constraints before I continue. Remember they give us constraints that when we are moving back, yes, steps greater than that. If you can only return x steps in the history, and x greater than x and step greater than x, you only return only x steps. That is, you cannot go beyond x steps. That there's a limit you cannot go beyond. Yes. So now what I want to do, I want to check current page minus steps. I want to check current page minus steps. If it's less than or equal to 0, remember I started from 1. So if it's less than or equal to, that's out of bound. We are going out of bound. So if it's less than or equal to 0, I want to make it on the home. I want to set it on the home page. That if you have gone back, if it goes out of bound, I want it to be on the home page, so you cannot go outside the home page. So now if it's not, that means I want to be able to retrieve that particular page. That is current page minus steps. Yes. So I will return map dot. I want to go and fetch that page. So map dot get current page. Yes. So for this one, I want to get, when I'm moving forward, I want to be able to get the number of steps forward. So when I move forward by current page plus number of steps that is given to me, I want to be able to kind of fetch that page. When it's greater than the maximum page, it should be a maximum page. It should not go more than that maximum page. So what I'll do is current page equal to current page. I want to check current page plus steps. If it's greater than or equal to max page, I want to set it to max page. Else, I want to fetch the page plus steps. Yes. So return map dot get current page. Yes. So I want to. So this is it. When the number of steps is given to me, I want to be able to. Okay, I move 2 steps forward. That is 2 steps. Add 2 steps to it. If it's not greater than or equal to the maximum page, then I should be able to fetch that page. But if not, it should just stop at the maximum page. So yes. So this is just the end of. This is just it. So let me check for syntax error. So this is close. Okay. This seems to be good. So let me run this code. Accepted. Yeah, correct. And let me submit it. Yeah, this code run perfectly well. So this is just it. This is just how to solve this problem. And this problem is the time complexity is big O of constant time complexity, that is big O of 1, and the space complexity is constant time space complexity, that is big O of 1 as well, because we didn't add any extra memory here. We add any extra place where we store values. We just use a map. So our maps, remember as I said, map insert and retrieve value at constant time. So the runtime is a constant time complexity, and the space complexity is constant time space complexity. So this is just it. So this is all about this problem. All right. Thank you very much for joining me today. Please remember to subscribe to my page and like my page, and also comment. I will also answer you on the comment, and tell me what you think about it. It's not really, it's very simple. It's a very simple problem. And this is a design problem, and this is the first design problem I'm going to be solving on this channel. So please, I want to be engaging. Please try to like and subscribe to my page. It gives me, it makes me, gives me encouragement. It makes me want to do more, put in my effort and go forward. At the same time, I'm motivated. This is what I do. I love doing what I do, and this is what I do every day. All right, thank you very much. You can hit me up on LinkedIn, Facebook, Twitter, Instagram, anywhere you can catch me on. Can talk to me, and I will try as much as possible to answer any question you have or reply any message. Yeah, once I'm chanced. Thank you very much. See you next time.